Okay, this video goes over Chapter 15 problems, a little bit on problem 13, more in depth on problem 14. Problem 13 is very similar to the example that we covered where we're selling calendars. We buy them for $7.50. We sell them for $10. We can send them back for $2.50 after our season is over. However, we only can send them back if we have more than 50. The first 50, if you have less than 50, you can't send those back. The average is normally distributed with a mean of 200 and a demand of 40. And the trick is we're trying to figure out an order quantity. We're trying to figure out what our order quantity should be. So certainly we're going to copy this down 100 times and run this simulation 100 times. We generate a random number. And then this formula is how we generate a random number from a normal distribution. Use the norm INV function referencing a random number, and then the mean, the standard deviation. I went ahead and made it round to an integer. Once you've got your random number, random demand, then what you sell is a function of your order quantity and demand. And if you notice, I have three different policies on this same spreadsheet rather than different worksheets. I've got a 200, a 160, and a 240. But I sell a minimum of those. What I salvage, and this is where you have to determine if the order quantity, if the leftovers, which is 200 minus your sold, if that is less than 50, then you can't salvage anything. Otherwise, you get anything over 50 that you can send back. So if we look at this particular example, the demand is 124. I have 200 on hand, so that's 76 that I have. That's over 50. So I can send back anything over 50, which is 26. In this one, I have 200. I have 21 left over. That's not over 50, so I can't salvage any. And once I know these three numbers, and I can determine my revenues based on selling at $10, salvaging at $2.50, and then subtracting my order quantity times $7.50. You calculate an average, a profit, and a confidence as a function of the standard deviation, some confidence level, and the sample size, and then we can plot these graphs. And this is just a plot of the averages where we're using error bars. Okay, so and in this case it looks like the order quantity 160 is probably better. It has certainly less variability. Sometimes order quantity 200, and there might be something between 160 and 200 that's better. You might want to try something like 170 or something. And I probably ought to order this differently, but that's okay. Problem 14 is that we've got two different seasons. We got a busy in season or a peak demand and an off peak. The peak demand, it's discrete. Demand is discrete. So 7,000 happens 5% of the time, 8,000 happens 10% of the time. So the first thing we do is build a cumulative distribution, start at 0, and after that, the next step up is what the number above it plus the probability above it. So how you can interpret that is that if you generate a random number between these two numbers, you'll get this. If you generate a random number between these two, you'll get this. Anything over this, the next one would be 1, so between 0.9 and 1 you would get this. So that's the peak demand, and the same thing for the off-peak, it's just not as much. You have an off-peak demand. And here's the probability assigned to that. So we can sell the peak demand at 25 bucks. We can sell the off-peak at 12.5, 50% off. It cost us $10. So again, we're trying to figure out our order quantity. So how I solve this is I first of all generated a random number and then calculated my peak demand using a VLOOKUP. I don't use the norm INV function. I'm using the VLOOKUP where I look up my random number in this cumulative distribution, grabbing the second column or the last column or the demand column, And the last argument is an approximate. You don't want to use 0. We're not looking for exactly that random number. That'll be rare that you find that. I also generate an off-peak demand with the same formula. I'm just using these. Now that I know what my peak and off-peak, I can determine how much I sell at peak and off-peak. What I can sell during peak is the minimum of my order quantity and the peak demand. If I have 15,000 on hand and my peak demand is 11,000, I can sell 11,000. And then what I have left over is 4,000. So I can sell, the first argument is my order quantity minus my peak demand, which is, or what I sold. So it's the leftovers previously, and then the smaller of that, and then my off-peak demand. So I've got how much I've sold at peak, at off-peak. Now that I've got these two numbers, I can calculate a profit. $25 against this, $12.50 for this, minus 15,000, my order quantity, times $10. Once I have this working, look what I did. I copied it into multiple worksheets. So this one's called 9,000, and the only thing is I changed the order quantity to 9,000. This one's 11,000. The only thing I change is the order quantity to 11,000. Once I have all these numbers, I got an average and a confidence. I can put those, and by the way, if you notice, I didn't do 10,012. I should, I just didn't. Here are all of my averages, and these are just referencing those worksheets. They're all cell F14. It's just they change based on which worksheet. Same thing on my confidences. These are just pointing to a cell value. But once you plot this, you can see you've got a pretty good story. Again, the smaller the order quantity, the less the variability. So as you move left to right, the variability increases, sorta. I'm hitting the F9 key to watch it run over different trials. And it looks like an order quantity between 11,000 and 13,000 is probably favorable. It seems like these two are the high ones. You might want to check 10,000 also. But the one that has the less variability is this one, which makes sense. So probably if you're trying to maximize expected value, you're probably closer to 11,000. If you're focused on risk or risk averse, you may want to move and have something closer to 10,000. Okay, that's the homework solution. Thanks.